Hi there, and welcome to the Air Equipment LLC YouTube channel. This is part 2 of our discussion on the basics of fans and blowers. The third and final type of impeller we want to talk about is the workhorse of the HVAC industry. It is a centrifugal impeller. Now, unlike an axial impeller, as you can see here on these images of various types of centrifugal impellers, the impeller has a bunch of small blades attached to a ring, and then when the assembly rotates, these little blades push the air away from the center, and that creates a low pressure area in the center, and so air is drawn in. But unlike an axial impeller where the airflow is pretty much straight through, here the air is drawn into the impeller parallel to the axis of rotation, but then once inside the wheel, it turns 90 degrees and then shoots off the wheel in a 360-degree pattern. There are many different types of centrifugal impellers. Backward incline is by far the most common. It can be either flat blade or airfoil blades. There's radial tips, forward curve. They're the economical squirrel cage type wheel, we call them, shown here in the lower right image there. There's radial blade type. It depends on the application, but in each case, the wheel, the impeller, is performing the same way. The little blades, when it rotates, push the air away from the center, creates a low pressure, draws air in, then the air turns 90 degrees and then shoots off the wheel. Here are images of the most common commercial HVAC fans, the power roof ventilator. And if you look closely, the one on the left is a downblast type fan, and the one on the right is an upblast. And you can tell by the way the discharge bell will be exhausting the air off of the fan. But the center part of the fan, the inlet at the bottom, and the centrifugal wheel, and the motor compartment with the shaft and the pulleys and the belts and the bearings and the motor, they're all identical. The only difference between these two fans is which way the air is going to leave the fan. So if you look, you can see the short blades of the impeller and the lower half of the fan. When that rotates, it draws air right up through the curb into the center of the wheel, and then the wheel, the air itself turns 90 degrees and will shoot off the blade shown here horizontally. And then after that, where the air goes is based on the shape of the discharge bell. As I said, the one on the left is downblast, the air will blow down onto the roof, and the one on the right is upblast, then that air will blow up and away from the fan. In our part of the world, in the northern half of the US, all things being equal, it's better to specify the fan on the left, the downblast type fan, because it cannot fill up with snow and ice. The fan on the right, if it's not running over the weekend and we get some snow or ice, it could fill up there and create a little glacier, and that blocks the airflow. However, the type of fan on the right, the upblast, is required for certain types of application, especially grease exhaust. Kitchen fans must be upblast. Laboratory fans must be upblast. Although this fan shown here is not a lab fan, you get my point that certain applications, we cannot be blowing that air down onto the roof. We have to get it up and away from the building as soon as possible. We'll take that same centrifugal wheel and mount it in a square housing, and it becomes a square centrifugal inline fan. The air is drawn into the center of the wheel, and you can see that on the left-hand image here. And then the right-hand image shows the back of the fan. So the air is drawn into the center of the wheel, it comes off the blades at 90 degrees, pressurizes that square plenum box, and then it leaves the box via the path of least resistance outside the back. And we use this type of fan quite often in inline applications, ducted on both sides, and it's a very efficient, very reliable way to move the air. Here's a little pop quiz for you. When is an inline fan not an inline fan? Well, it's when we use the side discharge option. Because this square inline fan is really just a pressurized plenum, that little centrifugal impeller is like a little plug fan. It's just drawing air in and pressurizing the box. The air is going to leave whichever is the path of least resistance. Most of the time, we have the back of the fan open, so the net effect is the air comes in one side and leaves the other in an inline direction, but nothing says we have to do it that way. If we put a panel on the back of the fan, and open up one of the sides and put a duck collar there, then the air will turn 90 degrees and shoot off the fan from the side. And the nice thing is there's no loss of performance. Because it's just a little pressurized plenum, the air is just going to leave via the path of least resistance. So this little option, this side discharge option, is really handy in cramped mechanical rooms. A lot of times we see an inline fan installed right next to an elbow, which is a very lousy either inlet or discharge condition, causes a lot of unwanted turbulence. So instead of having a fan, an inline fan, and then an elbow, let's just have the fan be the elbow. Put the fan in the corner with the side discharge option, and then the fan turns the air 90 degrees very efficiently with no loss of performance. So keep that in mind. In a cramped mechanical room or in a plenum area, the side discharge option might be a really good way to get out of a jam. We take that centrifugal impeller, mount it in a welded tube, and we have ourselves a tubular inline fan. This fan, of course, can only move the air in an inline direction. We can't turn the air 90 degrees off the side of a welded tubular housing. The centrifugal impeller is what's used for utility vent set and blowers. Very common workhorse fans in the industry, can move a lot of air against a lot of pressure, and sometimes, most importantly, can move a little bit of air against a lot of pressure. A blower type fan like this is so versatile. We use these almost exclusively in, say, vehicle exhaust applications where we might only need to move 600 or 700 CFM, but against 5, 6, 7, 8 inches of pressure, because it's those high velocity, small diameter ductwork we use, and this fan can do it. Can move a little bit of air against a lot of pressure. The centrifugal impeller is what's used in a big old double width, double inlet blower. Some of these fans are the size of a house, but it's the same principle. The blades create a low pressure in the center of the impeller. Air is drawn into the center, in this case from both sides, and then it follows the shape of the housing and discharges, in this case, out the lower left of this fan. This is a 73-inch diameter centrifugal impeller. That's a pretty big fan. And I suspect this is not the fan they're using for the bathroom exhaust, but you never know. Again, it's the same principle. Small blades attached to a ring. When it rotates, it creates a low pressure in the center. Centrifugal impellers are used in the fans that can also be laboratory exhaust. In this case, we have a blower where the air is coming in horizontally through the bypass section mixing box, then into the inlet of the fan. You can just barely see that. In the impeller is in yellow, just behind what's shown here in red, that isolation damper. The air is drawn into the fan. It turns 90 degrees off the wheel and then follows the shape of the fan housing straight up. And being lab exhaust, this one has a nozzle on the top with an induction type nozzle to dilute the air, get a high plume, and it's a good fit for laboratory exhaust. In our next segment, we're going to talk about fan curves and the fan laws. So please stay tuned.